It is possible to transform a difficult integral to an easier integral by using a substitution. We usually make a substitution for a function whose derivative also occurs in the integrand. For example, let us consider integral f of g of x times g dashed of x dx. We know that differential of g of x is g dashed of x. So let us substitute g of x as t. So this substitution has the effect of changing the variable as well as the integrand. Let us differentiate both sides. G dashed of x is equal to dt by dx. Cross multiply. G dashed of x times dx becomes dt. Therefore, the integral becomes f of t and g dashed of x dx becomes dt. Now it becomes a simpler function which can be integrated easily. So in order to master this technique, it is important that you practice a lot. And then in case if the function is of this form, say f dashed of x divided by f of x dx, we know the differential of f of x is f dashed. So let us substitute f of x as t in this case. Differentiate both sides because we have to substitute for dx also. F dashed of x dx is dt. Therefore, the numerator becomes dt and the denominator is t, which is now easy to integrate. It is log of absolute value of t. And substitute it back. The answer should be given in terms of x, not in terms of t. The given variable is x. So log of absolute value of f of x plus c it becomes. If the integral is of the form integral f of x multiplied with f dashed of x dx, this is an easy substitution. We will take f of x as t, differentiate both sides, f dashed of x dx becomes dt. Let us substitute, f of x is t and this becomes dt. See how simple the integration has become. T square divided by 2 plus c, and we substitute for t, which is f of x the whole square divided by 2 and plus c. This is how we do substitution. Let us derive few formulae. The first one, integral of tan x dx. Tan x is sin x divided by cos x. Let us take the denominator cos x as t. Differentiate both sides. Differential of cos x is minus sin x equals dt by dx. Let us cross multiply. So we get minus sin x multiplied with dx is equal to dt. Therefore, the integral becomes sin x dx is minus dt. Therefore, the numerator becomes minus dt divided by denominator cos x is t. Minus can be taken outside the integral. Integral of 1 by t is log of absolute value of t and plus c. Now substitute for t. T is cos x. So the formula for integral of tan x dx is minus log of absolute value of cos x plus c, or I may write cos as 1 by secant x. So it becomes which can be written as log of secant x whole power minus 1, and bring this 1 to this side, use logarithmic rule. So it becomes minus into minus is plus log of secant x. plus c. This is the formula for integral of tan x. Similarly, we can derive the formula for integral of cot x. Cot x is cos x divided by sin x. Let us substitute the denominator sin x as t. Differential of sin x is cos x times dx equals dt. The numerator becomes dt. We have this in the numerator divided by t. An integral of 1 by t is log of absolute value of t and plus c, the constant of integration. Log of, substitute for t, log of absolute value of sin x plus c. And I can write this sin x as 1 upon cosecant x, which is cosecant x power minus 1. Use the logarithmic rule. It becomes minus log of absolute value of cosecant x plus c. Therefore, the formula of integral of cot x dx is log of absolute value of sin x plus c or minus log of absolute value of cosecant x plus c. Write down these formulae in the formula book. Next formula, let us derive the formula for integral of secant x dx. Let us multiply both numerator and denominator by secant x plus tan x divided by secant x plus tan x times dx. The numerator becomes secant square x plus secant x into tan x divided by denominator is secant x plus tan x. Now we know that differential of secant x is secant x into tan x and differential of tan x is secant square x, which is in the numerator. Therefore, let us substitute secant x plus tan x as t. Differentiate both sides. Secant x into tan x plus differential of tan x is secant square x times dx is equal to dt. Let us substitute in this integral. The numerator becomes dt divided by the denominator is t. See how simple the function has become. Integral of 1 by t is log of absolute value of t, and now substitute for t. Log of absolute value of secant x plus tan x and plus c. Let us multiply by the conjugate log of secant x plus tan x into secant x minus tan x. Multiplying both numerator and the denominator by the conjugate, which is equal to, the numerator becomes secant square minus tan square. We have an identity. Secant square minus tan square becomes 1 divided by secant x minus tan x, which can be written as power minus 1, and use the logarithmic rule. It becomes minus log of secant x minus tan x under absolute value sign. Now let us write the formula for secant x. Therefore, integral of secant x dx is log of absolute value of secant x plus tan x plus c, or minus log of secant x minus tan x, conjugate of that. Similarly, we can derive the formula for integral of cosecant x dx. I am writing the formula directly. Same method we can apply. It becomes log of absolute value of cosecant x minus cot x plus c, or its conjugate, minus log of cosecant x plus cot x and plus c. So we have written the formulae for 4 trigonometric functions: tan, cot, secant and cosecant. Memorize these formulae. Let's do exercise 7.2. Question number 1. Integrate the functions. Integral 2x divided by 1 plus x square dx. Differential of x square gives us 2x. So we may substitute x square as t, or 1 plus x square also can be substituted as t. So it is better to take the whole denominator as t. Differentiate both sides. Differential of 1 is 0. Differential of x square is 2x equals dt by dx. Cross multiply. So we get 2x dx as dt, which is there in the numerator. 2x dx, same thing we have in the numerator. Therefore, this integral becomes dt divided by the denominator is t. Integral of 1 by t is log of absolute value of t and plus c, where c is an arbitrary constant. Now substitute for t. The answer should be given in terms of the given variable x. Don't give the answer in terms of t, and don't forget to substitute it back. Log of absolute value of 1 plus x square and plus c.
No need to write absolute value sign for 1 plus x square, because 1 plus x square is a positive value.
Second question. Integral log x divided by x, and we have whole square for the numerator. We know that differential of log x gives us 1 by x. We'll substitute log x as t. 1 by x dx is dt by differentiating both sides, and we have 1 by x dx, which becomes dt. Therefore, the integral becomes t square, and dx by x becomes dt. The integration is t cube divided by 3 and plus c. Substitute for t. T is log x. Log x is already there in the question. We need not write the absolute value sign for this. If we have integral of 1 by t like the previous question, we write log of absolute value of t. Here log x is already there in the question. Don't put absolute value sign. The whole cube and plus c. Third question. Integral 1 divided by x plus x log x dx. If you put integral sign, dx has to be written. Now we know that differential of log x is 1 by x. So let us rearrange this as, I can take x as a common factor. We get 1 plus log x dx. Now I can substitute log x as t or 1 plus log x as t. Differential of 1 is 0, and differential of log x is 1 by x dx is equal to dt. Therefore, the integral becomes dx by x. We have dx by x here, which becomes dt, and 1 divided by that bracket is t. And integral of 1 by t is log of, here we need to write absolute value sign, absolute value of t plus c, and don't forget to substitute for t, and our t is 1 plus log x. In log x function, x has to be positive, but log x can be positive or negative.
Therefore, we cannot remove the absolute value sign for 1 plus log x, because 1 plus log x may be positive or negative.
Question 4. Integral sin x into sine of cos x dx. Here we have composition of two functions. We will substitute cos x as t, the inner function. Differential of cos x is minus sin x dx. Don't worry about the negative sign. The negative sign can be taken to the other side. So sin x dx becomes minus dt. Sin x dx, we have sin x dx, which becomes minus dt sine of t. An integral of sine t is minus cos t. Minus of minus will become plus cos t. And substitute for t, therefore cos of cos x plus c is the answer. Question 5. Integral sine of ax plus b into cos of ax plus b into dx. Here we have so many methods. We can substitute sine of ax plus b as t, that is one method, or cos of ax plus b as t, that is another method, or we may multiply and divide by 2 and use sine 2 theta formula, that is the third method. So here I will substitute sine of ax plus b as t. Differentiate both sides. Differential of sine is cos of ax plus b into differential of ax plus b is a, chain rule, into dx is equal to dt. Cos of ax plus b dx is dt divided by a. Therefore, the given integral becomes dt divided by a. A is a constant. Pull out the constants which are in multiplication outside the integral. And then sine of ax plus b is t. 1 by a. Integral of t is t square by 2 and plus c. Substitute for t. And for different methods you will get different answers, but using the identities we can show that all the answers are same. Question 6. Integral root of ax plus b dx. I can write this as ax plus b whole raised to half dx, and this is a linear function. So I can use x power n plus 1 by n plus 1 integration formula. Therefore, it becomes ax plus b raised to half plus 1 divided by 3 by 2, and we have to divide by the coefficient of x, that is the differential of the base a, and plus c. Or you may do this by substitution also. You may substitute ax plus b as t, or you may substitute root of ax plus b also as t. This is a linear function, so direct formulae are applicable for linear functions, we know. So 2 divided by 3a, ax plus b raised to 3 by 2 plus c. Question 7. Integral x times root of x plus 2 dx. We will substitute x plus 2 as t, or root of x plus 2 also can be taken as t to avoid fractional powers. So let me take root of x plus 2 as t. Square both sides to make the differentiation easier. Now differentiate both sides. 1 plus 0, 1 plus 0 is 1. 1 dx is 2t dt. Dx becomes 2t dt. Now this is dx substitution. This is t, and for x we have to substitute. We can substitute for x from this equation. X from this equation is t square minus 2. If a constant is in multiplication, you can take it outside the integral. Now let us multiply. T square dt. We'll open the brackets. Now we can easily integrate each term. Integral of t power 4 is t raised to 5 by 5. And this becomes t cube divided by 3 and plus c. Don't forget to write the constant of integration and substitute for t. T is root of x plus 2. I can write it as power 5 by 2. 2 by 3. Root of x plus 2 power 3. So it becomes whole raised to 3 by 2 and plus c. Question 8. We know the differential of x square gives us x term. So we will take 1 plus 2 x square as t, or we may take root of 1 plus 2 x square as t. So let us square both sides to remove the root sign. Differentiate both sides. Differential of 1 is 0 and this is 4x dx is equal to 2t dt. Therefore, x dx becomes half t dt. Let us substitute. We have x dx in the question. It becomes half t dt, and let us substitute for this. This is t. Half is a constant, which is a factor. We can take it out. So half into integral t square dt. Integral of t square is t cube divided by 3 and substitute for t. 1 plus 2x square whole raised to 3 by 2. Root is written as power half. If you don't substitute with the root as t, you will get fractional power. But the final answer will be the same. Question 9. Integral 4x plus 2 into root of x square plus x plus 1 dx. Let us take x square plus x plus 1 as t, or with the root we can take to avoid the fractional powers. Square both sides to remove the root. Let us differentiate. Differential of x square is 2x and differential of x is 1 times dx is 2t dt. Now if you see in this question we don't have 2x plus 1, but by taking 2 out we will get the factor 2x plus 1. Now let us substitute. 2 is a constant. Let us remove it outside. And 2x plus 1 dx becomes 2t dt, and this term becomes t. 2 2s are 4, integral t square dt, which is so easy to integrate. It becomes t cube divided by 3 and plus c. Substitute for t. X square plus x plus 1 raised to 3 by 2. For root I have written power half and plus c. Question number 10. We will take root x common. So we get root x minus 1. We will substitute either root x as t or root x minus 1 as t. Differentiate. Root x is x raised to half. So differentiation becomes half x raised to half minus 1. Half minus 1 is minus half. Differential of 1 is 0. Dx is dt. This is 1 by root x dx, taking 2 to the other side. Now let's substitute. We have dx by root x. See, dx by root x, which is 2 dt, and this is 1 by t. 2 is a constant. Take it outside the integral. And now integrate. Integral of 1 by t is log of absolute value of t, and substitute for t. The answer is 2 times log of root x minus 1 plus c. Question 11. X divided by root of x plus 4 dx. Let us substitute x plus 4 as t, or root of x plus 4 also can be taken as t. To avoid fractional powers, it is better to take along with the root. Square both sides to remove the root sign. Differentiate both sides. Differential of x is 1. Differential of 4 is 0. 1 plus 0 is 1. 1 into dx is equal to 2t dt. Let us substitute. Dx is 2t dt, and root of x plus 4 is t, and to substitute for x we will use this. X is t square minus 4. So x should be taken as t square minus 4. Cancel these two t's. 2 is a constant which is in multiplication. We can pull it outside the integral. We have t square minus 4 dt. Let us integrate and write t cube by 3. An integral of a constant is 4t plus c. Substitute for t. X plus 4, root can be written as power half, so it becomes power 3 by 2 divided by 3 minus 4 times x plus 4 whole power half, and plus c. Root of x plus 4 can be taken out. So we get x plus 4 divided by 3 minus 4. Take LCM. It becomes x plus 4 minus 12. So x minus 8 divided by 3 plus c. So 2 by 3 times root of x plus 4 multiplied with x minus 8 and plus c. Question 12. Integral x cube minus 1 whole raised to 1 by 3 x power 5 dx. Let us substitute x cube minus 1 whole raised to 1 by 3 as t. Let us get rid of this power. Cube both sides. So x cube minus 1 becomes t cube. Differentiate 3x square. Differential of 1 is 0. Dx is 3t square dt. We need x square dx. We can split this x power 5 as x cube into x square. So that we can substitute for x square dx. This x square dx is t square dt, and this term becomes t. For x cube we can substitute from this. X cube is t cube plus 1. Let us open the brackets. t cube into t cube is t raised to 6 plus t cube dt. We have t here and t square, so we need to multiply with t cube, equal to integral of t raised to 6 is t raised to 7 by 7, and this is t raised to 4 by 4 plus c, and substitute for t, x cube minus 1 power 7 by 3 and plus 1 by 4 times x cube minus 1 power 4 by 3 and plus c. 13th question, integral x square divided by 2 plus 3x cube the whole cube dx. We know that differential of x cube term gives us x square term. So we can substitute x cube as t, or 2 plus 3x cube as t, or we may take 2 plus 3x cube, the whole cube also can be taken as t. So I am taking only 2 plus 3x cube as t. Let us differentiate. Differential of 2 is 0. This is 9x square dx is equal to dt. In the numerator we have x square dx, so it becomes 1 by 9 dt. Let us substitute. X square dx is 1 by 9 dt. 1 by 9 is a constant, so I have written it outside the integral. 1 divided by the denominator is t cube. I can write this as t raised to minus 3 and use x power n plus 1 by n plus 1 integration formula. So t raised to minus 3 plus 1, which is minus 2, divided by minus 2. Substitute for t. This is the answer. Question 14. Integral 1 divided by x into log x whole raised to m dx. X is greater than 0 because only for x greater than 0 log function is defined. We know that differential of log x is 1 by x, which is there in the function. We will substitute log x as t. Differential of log x is 1 by x dx, which is equal to dt. Don't take log x whole power m. You have to remove m before differentiation. Otherwise, you will get log x whole power m minus 1, which we don't have it in the function. Or you may take it as power 1 by m to the other side, but you will have fractional power. Therefore, better to avoid fractional powers. We will take only log x as t. Dx by x becomes dt. 1 divided by log x is t, so t raised to m, which can be written as t raised to minus m dt. Use x power n plus 1 by n plus 1 formula. So minus m plus 1 divided by minus m plus 1 plus c. Substitute for t, log x raised to 1 minus m divided by 1 minus m and plus c. Question 15. Integral x divided by 9 minus 4x square dx. We know that differential of x square is 2x. X term is there in the numerator. So we can take only x square as t, or the whole denominator can be taken as t. It is better to take the whole denominator as t. Differential of 9 is 0 and this is minus 8x dx equals dt. So x dx is dt divided by minus 8. X dx is dt divided by minus 8. Constant is written outside. 1 divided by, I have already substituted for x dx. Now the denominator is t. And integration is log of absolute value of t, substitute for t, this is the answer. Question 16, e raised to 2x plus 3 dx. We know that integral of e power x dx is e power x plus c. And in place of x, we have a linear function of x, 2x plus 3. So direct formula is applicable. The answer is e raised to 2x plus 3. But don't forget to divide by the coefficient of that x term or the differential of 2x plus 3. So divided by 2 and plus c. Question 17. Integral x divided by e raised to x square dx. We know that differential of x square is 2x dx. So we will substitute x square as t. 2x dx is dt. We have x dx in the numerator, which becomes half dt. Let us substitute for x dx, which is half dt. 1 divided by e power t. Let us write this as e power minus t. Don't write this as log of e power t. Integral of 1 by t is log t. This formula is applicable only for linear functions, not for exponential function. This is half. Integral of e power minus t is e power minus t divided by the coefficient of t is minus 1. Don't forget this, which is minus half into 1 by e power t plus c. Substitute for t. Question 18. Integral e power tan inverse of x divided by 1 plus x square dx. By looking at the function itself, we can make out that differential of tan inverse of x is 1 by 1 plus x square. So let us substitute tan inverse of x as t, or you may take e power tan inverse of x also as t. Differentiate both sides. Let us substitute. This becomes dt and this is e power t. Integral of e power t is e power t. And substitute for t. So e power tan inverse of x plus c.